It is the 17th of December 1944, a frozen crossroads near Street Vith, deep in the Ardennes forest. The temperature is hovering near 10 degrees Fahrenheit. The intense heat warped its armor plates and turned the interior into a hollow chamber of white ash and melted copper that would normally take a manufacturing plant in Detroit a week to complete. The final category on the officer's clipboard was the absolute write-off. If a tank was struck by a heavy anti-tank shell that ignited the gasoline and ammunition, the resulting inferno often warped the fundamental geometry of the steel hull. It could never fight again. But the triage officer did not abandon it. He marked it for salvage. Ordnance crews would strip it like vultures, tearing out the radios, the surviving machine guns, the road wheels, and the driver's periscopes. Only when every useful organ was harvested was the empty steel shell left to rust in the field. This system worked beautifully when the American Army was pushing forward. It transformed battlefield losses into a self-sustaining supply chain. But the entire mathematical structure rested on three delicate requirements: time, secure ground, and an abundance of heavy tractors to move the steel. The triage officer needed the luxury of standing over a vehicle to inspect it. The mechanics needed a secure perimeter to operate their cutting torches. Most importantly, the ordnance company needed enough heavy prime movers to drag away every piece of usable material. On the morning of the 16th of December 1944, all three of those requirements vanished. Out of the freezing fog of the Ardennes, a massive German counteroffensive, it is completely unrecognizable as a weapon of war. It is nothing but scorched, dead weight, smashed into a thinly held American line. The front did not just shift, it shattered. There was no time to walk the battlefield with a clipboard. There was no secure ground to set up an A-frame crane. And as American units desperately fell back through the snow, there were suddenly far more broken vehicles than there were wreckers to tow them. The delicate chain of recovery was forced into violent reverse. With the enemy closing in and only minutes to act, what specific components suddenly became more valuable than a whole tank? When the German artillery barrage opened at 5:30 in the morning on December 16, the mathematics of American vehicle recovery instantly collapsed. Three German armies poured through the freezing fog of the Ardennes, shattering the thinly stretched American lines. The front did not slowly bend. It broke. Suddenly, the slow, deliberate work of the ordnance companies turned into a desperate retreat. The narrow, ice-slicked roads of the Ardennes were instantly jammed, with retreating infantry, supply trucks, and artillery units. Tanks slid into ditches. Transmissions blew under the strain of frozen mud. Fuel ran out. Within 48 hours, the American Army had left dozens of stalled, bogged, and broken-down vehicles scattered across the snow. The echelon maintenance system was built for a static or advancing front. It assumed a limitless supply of time. Through the falling snow, a massive silhouette grinds into view. It is an M31 armored recovery vehicle. Now, time was measured in the minutes between the sound of approaching German tracks and the arrival of their vanguard. The triage officer's clipboard was useless. The mechanics operating the heavy M31 and M32 recovery vehicles faced a brutal new reality. They simply did not have enough engine power or steel cable to tow every disabled tank away from the advancing enemy. A heavy wrecker could only drag one 30-ton Sherman at a time. If an ordnance crew encountered a roadblock with 4 disabled vehicles, 3 of them were going to be captured. The rules of triage changed in an instant. The first new rule was denial. If an American tank was going to fall into German hands, it had to be permanently destroyed. Mechanics began carrying thermite grenades and satchel charges as standard equipment. An intact 75mm gun was no longer an asset. It was a severe liability if it was captured and turned around to fire at retreating American convoys. The second new rule was survival of the fleet. The recovery crews were no longer trying to save individual vehicles to repair later in the week. They were trying to save the specific, irreplaceable donor organs required to keep the surviving combat formations fighting that exact night. Supply lines from the ports at Antwerp and Cherbourg were cut or frozen. The rear echelon depots were packing up and retreating, a heavy, crane-equipped machine built specifically to drag wounded armor from the battlefield. Two mechanics from an American ordnance company. There would be no fresh shipments of spare parts arriving. The only spare parts the American armored divisions possessed were the ones currently sitting on the battlefield. This forced the ordnance mechanics to perform a ruthless, split-second calculus under mortar fire. If they hooked their wrecker to a tank, they were not saving a hull. They were saving whatever rare mechanical component happened to be bolted inside it. If a retreating armored battalion desperately needed Sherman transmission housings to keep its remaining tanks moving, then transmissions became the most valuable currency on the battlefield. A completely intact Sherman with a broken transmission was dead weight. It could not drive, and towing it away would not provide the battalion with the parts it needed. But a completely burnt-out hull that happened to have an intact transmission bolted to its front was a gold mine. Under the intense pressure of the winter collapse, the illusion of the whole tank was finally and completely shattered. The mechanics stopped seeing vehicles entirely. They only saw supply bottlenecks on tracks. With German infantry closing in through the pine trees and artillery shells shattering the frozen ground, the recovery crews had to look at two broken vehicles, jump down into the knee-deep drift. The German artillery is no longer distant. Mortar shells are beginning to shatter, and decide which one held the key to the division's survival. To understand how they made that choice, we must return to the frozen crossroads and the exact mechanical components that suddenly became more valuable than whole tanks. We return to the freezing crossroads near Street Veith. The mortar shells are walking closer, throwing jagged wood and snow across the road. The infantry corporal is still watching from the tree line, waiting to see if the ordnance crew will save the pristine Sherman with the broken track, or the blackened, burnt-out husk. He watches the mechanic drop a thermite grenade into the intact tank, destroying it instantly. He watches the heavy wrecker hook its cables to the charred scrap and violently drag it away into the snow. It looked like panic. In reality, it was a perfectly executed industrial equation. The pristine Sherman had snapped a drive sprocket and damaged its final drive assembly on the ice. In Normandy, or even a month earlier in France, it would have been heavily prioritized for recovery. But in the desperate retreat of the Ardennes, the triage sergeant knew the logistics ledger. The American supply depots in that specific sector were completely out of replacement Sherman transmissions. Towing that 30-ton machine to the rear would not save a weapon. The pine trees just 300 yards away, showering the road with jagged wood and hot shrapnel. The crew has perhaps 5 minutes. It would merely relocate a massive steel paperweight that could not fire, could not move, and could not be repaired before the German vanguard arrived. Worse, because it was largely intact, leaving it behind meant handing a functioning 75mm gun to the enemy. The German army was notorious for turning captured Allied armor against its former owners. The thermite grenade was not an act of madness. It was a mandatory execution to deny the enemy a working artillery piece. But the burnt-out husk was a different story. The fire had melted the turret, destroyed the engine, and warped the upper armor plates, rendering the crew compartment completely useless. However, the heat had not reached the massive steel suspension bogies and road wheels bolted to the lowest edges of the lower hull. Those heavy exterior modules were scorched, but structurally sound. The retreating American armored units did not need a whole tank. They desperately needed suspension parts. In the motor pool safely behind the American lines, 5 other Shermans were currently immobilized by landmine damage to their tracks and wheels. Without replacement bogies, those 5 tanks were dead. By risking their lives to hook cables to the burnt-out scrap, the ordnance crew was not saving a tank. Before the enemy vanguard clears the ridge, they only have the time and the engine power to tow 1 vehicle away. They were harvesting the exact mechanical organs required to fix 5 other vehicles before the sun came up. To the infantrymen, the mechanics had destroyed a treasure and saved a piece of garbage. To the ordnance crew, they had destroyed a liability and secured the survival of a platoon. The math was brutal, cold, and undeniably effective. As the American lines fell back, this exact scene played out across dozens of crossroads and frozen fields throughout the Ardennes. American mechanics systematically blew up pristine vehicles they could not fix, and aggressively towed away shattered wrecks holding vital spare parts. But there was a third audience watching this process unfold. Within hours, the advancing German Panzer spearheads captured these identical Streetvith crossroads. They found the deliberately sabotaged American armor and the strange absences where useless scrap should have been left to rot. When German officers inspected the battlefield, they tried to read the American strategy. What they saw deeply reinforced their own sense of superiority, yet left them completely blind to the industrial machine, operating just over the horizon. How did the advancing enemy misread this battlefield behavior when they captured the ground? When the vanguard of the 5th Panzer Army reached the Streetvith crossroads later that afternoon, the snow was still smoking. The infantry corporal watches, knowing exactly what must happen. The recovery crew needs to rig the intact Sherman. German officers stepped down from their half-tracks to inspect the prize. What they found was a pristine American Sherman sitting silently in the cold. To the advancing Germans, this was a familiar and welcome sight. They had been taught by their own command that the American soldier lacked the hardened discipline of the Wehrmacht. Seeing an abandoned, externally perfect tank seemed to confirm their deepest bias. It looked exactly like the panicked flight of a defeated, routing army. A German maintenance crew quickly climbed onto the olive-drab hull, hoping to press the captured vehicle into service. The Wehrmacht relied heavily on captured enemy equipment to supplement their own straining factories. But when they forced open the heavy steel hatch, the bitter smell of melted copper and scorched grease hit the winter air. Inside, they found a fused, slagged ruin. The thermite grenade had permanently welded the 75mm gun breech to the recoil guard and warped the turret ring. Visually, it was a tank. Mechanically, it was a tomb. The German officers could not comprehend the logic of the debris. Why had the Americans taken the time to execute a machine with only a broken track? Yet the deep grooves in the snow clearly proved they had risked their lives to tow away a completely burnt-out wreck. The confusion stemmed from the fundamental difference: save the combat power and fall back. Instead, the ordnance sergeant ignores the prize. He climbs onto the hull of the pristine tank, in how the two nations built their war machines. German armor was a masterpiece of bespoke engineering. Tanks like the Panther and the Tiger were heavily armed and thickly armored, but they were not designed for aggressive battlefield cannibalization. If a Tiger tank shattered its complex, overlapping road wheels, it could not simply borrow interchangeable parts from a nearby wreck in the mud. German manufacturing suffered from constant, hyper-specific modifications on the assembly line. Two German tanks of the same model built only months apart might require entirely different transmission gear ratios or suspension bolts. Because of this lack of standardization, when German heavy armor suffered a major mechanical failure, Frontline mechanics were often powerless. The vehicle usually had to be loaded onto a specialized heavy rail car and hauled hundreds of miles back to a factory in Germany for a bespoke rebuild. Because their own system was rigid and deeply reliant on the factory, the German commanders fundamentally misread the American wreckage. They looked at the thermite-gutted Sherman and saw the desperation of a collapsing front. They did not realize they were looking at ruthless, standardized industrial efficiency. The American mechanics were not fleeing in blind panic. They were executing an organized, tactical contraction of their supply chain. The German army was capturing miles of freezing forest and dead steel, but they were failing to capture the actual combat power of the United States Army. Pulls the pin on a thermite grenade, drops it directly down the open commander's hatch, and slams the heavy steel lid shut. That power was currently rolling away on the back of heavy wreckers, carrying the exact donor organs required to fix the surviving fleet. The enemy could measure their advance by the ground they took and the abandoned hulls they counted. But they could not see the hidden machinery operating just out of artillery range. As the German offensive pushed deeper into the Ardennes, extending their own fragile supply lines to the breaking point, the American armor they thought they had permanently destroyed was quietly preparing to return. What was the final operational impact of this brutal, unglamorous American triage system when the sun finally came up? 10 miles behind the collapsing front, concealed in a dense pine forest, the American recovery system was running at maximum capacity. The clearing was illuminated by the violent blue glare of acetylene torches and the yellow glow of shielded work lamps. This was a third echelon maintenance depot. It was an industrial factory built in the freezing snow. Here, the burnt-out scrap hauled away from the Streetvith crossroads finally proved its worth. Heavy A-frame cranes, mounted on the backs of recovery vehicles, hoisted the scorched, heavy suspension bogies from the ruined hull. Mechanics wielding heavy sledgehammers and pneumatic wrenches knocked out the retaining pins. For the American infantrymen shivering in shallow, ice-rimmed foxholes, the morning is defined by two distinct sounds. A blinding white flash bleeds through the vision slits. At 4,000 degrees Fahrenheit, the chemical fire silently melts. Within hours, those salvaged components were bolted onto the lower hulls of 5 other Shermans that had been crippled by landmines. This was the rolling resurrection. By treating tanks not as singular machines, but as vast collections of interchangeable hardware, the United States Army bent the laws of armored warfare. When a German panzer division lost 20 tanks in a bitter winter engagement, those vehicles were essentially gone. Their bespoke engineering required factory rebuilds that the crumbling German rail network could no longer provide. The German combat power strictly degraded with every mile they advanced. The American divisions operated on a completely different mathematical curve. An American armored battalion might report a staggering loss of 30 tanks during a single day of fighting. To the German intelligence officers intercepting those casualty reports, it sounded like annihilation. But overnight, the ordnance companies would perform their brutal mechanical surgery. They cannibalized 10 ruined hulls to harvest the transmissions, tracks, and engines required to save the other 20. When the sun came up the next morning, the German panzer crews expected to face a shattered, depleted American battalion. Instead, they stared through their gun sights and saw 20 fully operational Shermans idling in the tree line, ready to counterattack. The enemy was fighting a phantom arithmetic. They were destroying American vehicles, but they were fundamentally failing to destroy American combat power through the gun breach, fusing the turret ring and destroying the engine block. In seconds, the perfect tank is permanently dead. This hidden logistical system was the true anvil that broke the German winter offensive. As the Ardennes campaign dragged into January, the Wehrmacht bled out its irreplaceable armor in the snow. The American forces simply absorbed the shock, cannibalized their dead, and rebuilt their armored spearheads in the freezing mud. The massive industrial output of the United States did not just cross the ocean on cargo ships. It rebuilt itself every single night on the battlefield. But systems are not magic. They do not run on doctrine or engineering manuals alone. The interchangeable parts, the standardized hulls, and the cold calculations of the triage officers were only the inert tools of recovery. Making that system work required an immense amount of physical labor in the worst possible conditions. Underneath the statistics of victory, there was a heavy, unglamorous toll exacted on the men forced to execute this equation. The mechanics were not fighting the enemy with rifles, but they were fighting gravity, weather, and the sheer, crushing weight of frozen steel. To fully understand the American war machine, we have to look past the recovered tanks and look at the men who pulled them out of the fire. What was the physical and human cost for the mechanics who lived their war in the graveyard shift? Then, the mechanics run to the burnt-out husk. Working frantically under the incoming fire, they drag heavy, ice-coated steel cables to the blackened shell. The system of standardized cannibalization was a masterpiece of industrial logic. But blueprints and doctrine do not turn wrenches. The invisible machinery of American logistics was powered entirely by exhausted, freezing men. The mechanics of the Ordnance Department did not win medals for charging machine gun nests. They fought a quiet, agonizing war against gravity, weather, and the sheer, crushing weight of dead steel. To turn a destroyed Sherman into a fleet of survivors required brutal physical labor. The reality of the graveyard shift meant a 19-year-old mechanic lying on his back in a puddle of freezing Belgian mud, trapped underneath 30 tons of crippled armor. He had to manipulate heavy steel bolts with bare, frostbitten hands because thick winter gloves were too clumsy to feel the threading. The temperature hovered near 10 degrees. The transmission fluid leaking onto his uniform immediately froze into a stiff, toxic crust. And every time the wind shifted, he inhaled the sharp, bitter scent of scorched paint and the ashes of the vehicle's former crew. These were the uncelebrated laborers who made the cold arithmetic of the battlefield real. They were the welders staring into the blinding blue glare of an acetylene torch, while German mortar shells shattered the pine trees just a few hundred yards away. They were the wrecker drivers. The mechanics tear off their gloves to manipulate the locking pins, freezing their bare hands to the metal to secure the massive rig, wrestling with heavy ice-coated steel cables that could snap under tension with enough kinetic force to cut a man in half. They were the clerks, the truck drivers, and the triage officers operating on days of no sleep, marking salvageable components in the dark. When the German army looked at the American military, they saw the vast manufacturing output of Detroit and the endless convoys of supply ships. They assumed the Allies possessed an infinite mountain of pristine equipment. They did not see the desperate, bleeding hands of the men stripping burned-out wrecks in the snow to keep that illusion alive. The mystery at the Street Vith crossroads was never really about why an ordnance crew destroyed a pristine tank to save a piece of charred scrap. It was about the fundamental difference between a weapon and a war machine. A weapon is a single, isolated object that degrades every time it takes a hit on the battlefield. A war machine is a sprawling, ruthless, interconnected network of labor, standardized parts, and cold calculation that can rebuild its own severed limbs in the dark. We return to the edge of the tree line. The infantry corporal watches the massive M31 recovery vehicle dig its tracks into the black ice, to a piece of useless garbage. The recovery vehicle revs its engine, pouring thick black exhaust into the winter air. Thick diesel exhaust pours into the winter air, momentarily hiding the falling snow. The mechanics, their knuckles raw and bleeding from the frozen metal, hammer the locking pins into the towing shackles of the blackened, hollowed-out hull. They do not look back at the visually perfect Sherman. They just execute it with thermite. They do not have time for sentiment, and they do not care how the battlefield looks to the advancing enemy. The vanguard is closing, the temperature is dropping, and 5 crippled tanks are waiting in a forest 10 miles away. The heavy engine roars, the thick steel cables pull taut, and the mechanics drag their ugly, priceless prize away into the freezing fog to build another survivor. Its tracks spin on the ice, finally catch, and violently drag the scorched, hollowed-out scrap metal away toward the American lines. To the infantrymen freezing in the dirt, the scene defies all military logic. Under the pressure of a massive enemy breakthrough, the mechanics deliberately destroyed a weapon that could have been used to defend the line tomorrow, only to risk their lives dragging away a piece of trash. But the ordnance crew had not panicked, and they had not made a mistake. They were executing a precise, calculated equation. To understand why they burned the treasure and saved the scrap, we first have to understand the rhythmic thud of advancing German artillery and the frantic roar of retreating American transport engines. How the men on the fighting line were trained to see their vehicles, and why the mechanics knew that vision was a dangerous illusion. To the infantrymen shivering in the Ardennes, a tank was a singular, complete object. It was a 30-ton cavalry horse of steel. When a tank crew received their M4 Sherman, they did not view it as a collection of separate components. They painted a name on the gun barrel. They stored their rations in the sponsons and slept against the transmission housing to stay warm. They relied on the thick slope of the frontal armor to keep them alive. To the men who fought inside them, and the infantry who fought behind them, a tank was whole. If the engine turned over and the 75mm gun could still fire, the machine retained its identity. It was simply a tank that could not move at this exact moment. Early American military doctrine reinforced this natural expectation. When a combat command launched an offensive, line commanders demanded maximum operational readiness. To maintain momentum, the armored forces needed their firepower returned to the front as rapidly as possible. The initial logic of battlefield recovery dictated a clear priority system. Save the easiest repairs first. An infantry corporal watches the chaotic withdrawal from the edge of the tree line, just 50 yards down the road. If a Sherman snapped a track pin or blew a road wheel on a landmine, it was classified as lightly damaged. The vehicle was fundamentally intact. Field manuals instructed recovery teams to prioritize these mobility kills. Pull the tank behind a berm, wrestle a new heavy steel track block into place, tighten the tension, and send the 30-ton asset right back into the fight. The math seemed obvious. Why spend 10 hours dragging a completely destroyed wreck to the rear when that same time could be used to tow 3 lightly damaged tanks to a repair depot and get them shooting again? This was the logic of the local battlefield. It was a perspective based entirely on immediate tactical survival. The infantry corporal watching the Street Vith crossroads applied this exact logic. He saw a pristine machine with a broken drive sprocket. He knew it was only a few bolts and a heavy lift away from functioning perfectly. Destroying it with a thermite grenade felt like an act of madness, or perhaps panic. But the men of the Ordnance Department did not live in the tactical reality of the front line. They lived in the logistical reality of the supply chain. 2 disabled M4 Sherman tanks sit abandoned in the deep snow. They are 2 entirely different machines. A tank commander saw his Sherman as one unified machine. The ordnance mechanic saw it as a temporary cluster of exactly 4,500 separate, interchangeable parts. The infantryman believed that a tank with only one broken part was 99% ready for combat. But in the cold equations of military logistics, a tank missing a vital component was exactly as useless. as a tank that had been blown into 1,000 pieces. Neither of them could move, and neither of them could fight. The infantryman's common sense expectation rested entirely on a single, invisible assumption. He assumed that the supply depot sitting miles behind the front line actually possessed the replacement sprocket required to fix the lightly damaged machine. That assumption was often false. Moving millions of tons of steel across 3,000 miles of ocean meant that supply pipelines were constantly choking. The true value of a shattered vehicle on the battlefield was not determined by how much armor remained intact. It was determined by a ruthless mechanical triage that viewed every broken tank not as a tragedy, but as a quarry. The Atlantic Ocean was a 3,000-mile friction point. Every spark plug, track shoe, and turret motor had to be manufactured in places like Detroit. The first Sherman is practically pristine. It threw its right track on black ice and snapped a drive sprocket, loaded onto a Liberty ship, escorted past German submarines, offloaded at a damaged port like Cherbourg, and trucked through freezing mud to the front lines. A replacement drive sprocket sitting in a wooden crate in Michigan was entirely useless to a stranded armored column in Belgium. Because the supply pipeline was constantly interrupted by weather, distance, and enemy action, the Ordnance Department had to generate its own supply chain directly on the battlefield. They did this through aggressive, systematic cannibalization. To the men turning the wrenches, a disabled Sherman was not a casualty, it was a donor. The American M4 medium tank was deliberately engineered for this exact fate. Unlike many bespoke European designs, the Sherman was built with modularity in mind. Its massive final drive assembly was bolted directly to the front of the hull, rather than buried deep inside an internal chassis. Its suspension bogies were external modules that could be unfastened and swapped. The engine compartment was standardized to accept completely different power plants without requiring the factory to redesign the tank. When a battalion maintenance officer walked a battlefield after an engagement, he carried a mental ledger of his division's critical shortages. He did not look at a blown-up vehicle and see a tragic loss of 30 tons of steel. He looked at a smoldering wreck, but its armor is unpierced. Its 75mm gun is perfectly intact. It is a 30-ton asset of combat power, and saw a perfectly intact V8 engine, 3 usable suspension springs, and an undamaged radio set. If a German armor-piercing shell gutted a turret and sparked an internal fire, the tank was destroyed in the eyes of the infantry. But if the heavy transmission in the lower front bow survived the heat, that destroyed tank suddenly became the most valuable asset in the sector. It held the exact mechanical organ required to save another vehicle sitting miles away in a motor pool. This was the cold arithmetic of scrap. One tank with a cracked engine block and another tank with a shattered turret did not equal 2 dead tanks. Under the hands of an experienced ordnance crew, they equaled 1 fully operational combat vehicle and a pile of discarded metal. Mechanics were explicitly authorized to strip the dead to save the living. They used acetylene torches to cut away ruined armor, wrestled heavy chains around intact transmissions, and hoisted thousands of pounds of greasy, freezing metal out of shattered hulls, using the heavy booms of their recovery vehicles. They salvaged generators, periscopes, and track links, leaving only the stripped, hollowed-out skeletons behind in the dirt. This system of organized cannibalization allowed American armored divisions to absorb staggering losses and regenerate combat power without waiting weeks for supply convoys. That merely needs a tow and a few hours in a rear echelon motor pool to be fully operational again. It essentially turned the battlefield itself into a massive, decentralized spare parts depot. Under normal conditions, this process was highly deliberate. A triage officer would carefully assess each vehicle, tag the salvageable components, and dispatch wreckers to haul the donors to a rear echelon field hospital. They had time to unbolt the housings, drain the fluids, and categorize the scrap. But the system was built for an army that was advancing. It relied on the fundamental assumption that American forces controlled the ground and owned the hours required to perform heavy mechanical surgery. That assumption evaporated in the third week of December. What happens to this delicate mathematical chain of recovery? When the front line suddenly collapses, the enemy takes the field, and a mechanic only has 5 minutes to decide what lives and what burns. Before the winter crisis hit, this triage system operated with the disciplined rhythm of a medical clearing station. When the guns fell silent after a typical engagement in France or the borders of Belgium, an ordnance officer would walk the contested ground. He carried a clipboard, a piece of heavy chalk, and the immense responsibility of deciding the fate of thousands of tons of damaged steel. He evaluated each casualty using a strict, multi-tiered framework known as the echelon system of maintenance. The rules were pragmatic, driven by time and distance. The second Sherman is a corpse. Hit by a German anti-tank round 3 days earlier, it burned for over 12 hours. To make his decision, the officer did not simply glance at the exterior armor. He crawled underneath leaking hulls to inspect the heavy differential housings. He smelled the dark pools of transmission fluid for the bitter scent of scorched gears. He checked the internal ammunition bins for signs of sympathetic detonation. If a Sherman suffered minor damage, a thrown track, a bent drive wheel, or a clogged fuel line, it was classified as first or second echelon work. The tank crew or the battalion mechanics would fix it in the mud, using their own hand tools, usually within a few hours. But if the damage was severe, a shattered transmission, a pierced engine block, or a sheared turret ring, the officer had to make a much heavier calculation. He had to look past the blackened steel and assess the surviving internal organs. If the tank could be saved with a major component swap, he marked the armor with a heavy chalk cross. Massive M31 recovery vehicles would then hook their steel cables to the casualty and drag it back to a third or fourth echelon maintenance depot, safely out of artillery range. These intermediate depots were open-air factories hidden in European forests. Here, mechanics with heavy A-frame cranes, block and tackle rigs, and acetylene welding torches could lift entire 3-ton engine assemblies out of the hull. They performed heavy mechanical resurrections in 24 hours,